This is the Math 2 lesson summary video for the lesson entitled Under Construction. The purpose of this lesson is to use circles and lines to construct geometric figures. We specifically will focus on constructing equilateral triangles and squares through the use of perpendicular bisectors as well as circles. This word to construct in geometry means that we're going to use a straight edge, also known as a ruler, as well as a compass to construct these equilateral triangles and squares. What we discussed in class was how to, in number 1, construct an equilateral triangle. So we were allowed to try and figure out how to get an equilateral triangle, which means that all 3 sides are congruent in length, how to construct that equilateral triangle. So what we did was we took a compass, and if you did miss class, we can work on you using a compass, but we took a compass, and what we did was we drew 2 circles with the same radius. So if you look at the circle that I just drew, the radius of this circle is the line segment ST. And if I draw another circle, hopefully in a different color, there it is, in blue, and it has, the blue circle has a radius also of line segment ST. So what we discussed in class is that if we were to put a point on where those 2 intersect, the blue and the green, if we put a point right there, we should be able to construct an equilateral triangle if we connect that point that's created with each of the endpoints. Now, we discussed in class why mathematically that is so, because we know that ST, line segment ST, is a radii of circle S, so we can mark it with 1 tick mark. We also know that line segment, let's call this SR, is a radii of the same circle, the green circle, so we know that those have to be congruent. And if we look at the blue circle, if we know that TS, line segment TS, is congruent to line segment RS, then in the blue circle, we would also know that these would be congruent to TR, given that TR is a radius in the blue circle. So we can see that that triangle right there is equilateral. The next thing that we moved to in class was we were given a line segment RS, as demonstrated below, and we folded our paper to crease R on top of S. Okay, so then we drew what we would call a perpendicular bisector. So what we discussed, when we draw that perpendicular bisector, it means that it's going to split our line segment RS into 2 equal parts. So without having folding this paper in front of me, what I'm going to do is I just drew a smaller line segment, and I am going to demonstrate how in class we constructed the perpendicular bisector without paper folding of this line segment. So I took my compass and I put it on one endpoint. This is what we discussed in class. And I opened it so that it was more than 3/4 of the line segment, and I drew a circle. And students in class said, well, if we move this endpoint over to S and we draw another circle with the same radius, excuse me, we will get 2 intersecting arcs right here and right here. And if we connect those green line segments, see if I can get it right down the center. 3 times the charm. Maybe not. Let's put it right here, down the center. There we go. So now that we have a perpendicular bisector, we can call this point. The book wants to reference this point as point M. So now that we can say we've just constructed the perpendicular bisector by constructing congruent circles centered at each of the endpoints of the segment. So you can see that this is a center. R is a center of the red circle, and S is a center of the blue circle. So we've created two congruent circles, and where they intersect creates a perpendicular bisector. So that definition of a perpendicular bisector tells us that my line that I just drew, I can say that line segment RM will be congruent to line segment SM by definition of a perpendicular bisector. And by definition of perpendicular, we do know that these will be right angles. Okay, so in number 4, they're asking us to label the midpoint of line segment RS as point M. And then using that line segment, they want us to construct a square. Well, what do we know about a square? We know that all 4 sides are congruent length. So if we were to take our compass and make sure to physically measure the length of the radius from point M to point S, we know has to be equal distant. So what we can do is open our compass to that length and then draw a circle. Then we're going to move our compass over to point S. We're going to draw another circle and leave our compass the same opening because that will give me the same radius as the original circle. And then we're going to go up to point N and we're going to construct another circle. And I'm going to label this point at the top of intersection. Doesn't really matter, but point, let's say it's point P. Well, what we know is that our square, the length from here to here will be equidistant from here to here. And then we also know that our square then is constructed right here. So all 4 lengths will be of equal distance. If you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.